All right, you guys finally left, and I'm starting this right now again. So number 7, if I did it again from the beginning, because we kind of rushed it. If I look at number 7, you're given the derivative, and it's a horizontal line. To integrate, you find the area under the curve. The area is a rectangle. And if I look carefully, 1, 2, 3, 4, 5, the length of the rectangle is 5. The width or the height of this is 3, and the area of a rectangle, length times width, would be 5 times 3, which is 15. If I wrote the equation of that, it would just be 3. A horizontal line would be y equals 3, but we don't have y. Instead, it's the derivative equal to 3. If I integrate that, 3, it's just 3x, but we can't forget the candy. And then it tells me plug in 1 for x, and the y coordinate is 4. Let me do that over here on this side. So if I do that on this side, the y coordinate is 4. X is 1. And then I'm going to solve for c. So 3 times 1 is 3. Subtract 3 to 4. So 4 take away 3 is 1. So what is this equation? Instead of 3x plus c, I can now write down 3x plus 1. That's that. And then the last question says, hey, plug in f at 5, plug in f at 0, and then subtract them. So if I said, okay, what's f at 5? And then take that and subtract and plug in 0. So into the function, if I plugged in 5, 3 times 5 is 15, plus 1 is 16. If I plug 0 in, 3 times 0 is 0, and 0 plus 1 is 1. 16 take away 1 is 15. And voila, they match each other. The area under the curve. Notice the upper and the lower bound. And here we're going to discover how do we do a definite integral. This idea of substituting the bounds. My lower bound was what number? 0. My upper bound was what number? 5. Plug in 5, you plug in 0, and you subtract, and it gives me the answer of the integration. That's what it means. That is a definite integral. You integrate, and then you plug in the bounds and subtract the answers. That's how you do it by hand and without a calculator. All right, let's look at that again. Number 8. Here you're given the derivative of a line. If it says find the integration using the graph, what you would do is you'd recognize there's triangles. So there's a triangle above and there's a triangle below. I'm going to shade that in. The triangle above, I'm going to start with. It's positive area. That's 1/2. The base in this case, the scale's counting by ones. So the base in this case is 2. And the height is 1, 2, 3, 4. And then we're going to subtract the triangle that's underneath. So the area underneath is negative. Again, half the base times the height. So the base is 1 and the height is 2. When I put that together, 2 times 4 is 8. So half of 8 is 4. 2 times 1 is 2. Half of 2 is 1. So altogether, to integrate, the answer was 3. That's integrating by graphing. We're going to learn to integrate with my calculator. Integrate by graphing, and it's the shaded area that's trapped between the function and the x-axis. And if it's above the x-axis, positive area, below the x-axis, negative area. So you can tell the part underneath is far smaller. Oh, there's the bell to start third period. The part underneath is far smaller than the part on top. So you can tell the end answer better be positive, which it is. All right, write an equation for this line. How do you write an equation of a line? I know you can do mx plus b. So what is the y-intercept? It's 2. What's the slope? up 2 and to the right 1. So the slope is up 2 and to the right 1. That's 2x. The y-intercept is 2. So the derivative, or the equation of that line, is 2x plus 2, mx plus b. All right. Now, find f at x if you have a point. Now, 1, 0, 1, 0 is a point on your line. So if you went 1 to the right, 1, 0 is a point on f at x, not the derivative. So you're given a point on the function. That means, we have to integrate this, right? So that's an equation of this. Integrate it, then plug it in. So if I integrate this, it's x squared divided by 2. So the 2's divide. So if I integrate it, it's x squared. Remember how I can double check quick? Take the derivative of x squared and it's 2x. The integration of 2 is 2x, because if you take the derivative of 2x, it's 2, and then the constant at the end. Plug in, and again, in this case, the y value is 0, the x value is 1, and then solve for c. So if we do the math correctly here, 1 squared is 1, 2 times 1 is 2, add it, it's 3, subtract it, so that c is equal to -3. So if I put it all together, the function is x squared plus 2x subtract 3. If I take the derivative of that, I get 2x plus 2, and that's what the derivative looks like. And when I find the area underneath that, I'm integrating. All right, how do I do it without a graph? Well, I'm going to plug in the bounds. So if I look at the x values, what's the lower bound and what's the upper bound? So the upper bound is the one on the right, and the x value of the upper bound is +1. The x value of the left bound is -2. You plug in the upper bound, you plug in the lower bound, and you subtract the two answers. So plug it into the equation. So if I plug 1 into this equation, you get 1 squared plus 2 times 1, take away 3. That's 1 plus 2, take away 3. Altogether, that is 0. So I plugged in +1, and I got the answer 0. Plug in -2. -2 squared is +4. 2 times -2 is -4. And then subtract 3. So it's 4, take away 4. That's 0. Take away 3. So that's -3. So what's 0 subtract -3? The answer is +3. Voila. And what we're discovering is the fundamental theorem of calculus. How do you do a definite integral without graphing? And you integrate and you plug in the bounds. It's the upper bound, subtract the lower bound. That's what we're learning. All right, number 9. You're given an equation. X at t equals that. That's a position equation for an object moving along the x-axis. It says find the displacement. Man, that's a summer school word. Displacement. Displacement simply means where did it end, where did it start, and you subtract the two. So that's all I care about. I don't care what it did in between. I just care where did it end and where did it start. So what is my upper bound? Where did it end? So we're going to plug in. I'm going to do that down here so you can see it. So for part A, I'm going to plug in 4. That's where it ended. I'm going to plug in 1, and then I subtract the 2. And that's called the displacement. The other word that goes with displacement is total distance. And total distance, it matters if it's going to the right and going to the left. Total distance is what's the distance going to the right, what's the distance going to the left, and then you add it all as a positive area. Displacement doesn't care. Where did it end? Where did it start? And that's the displacement. So if you plug in 4 for t, 1/2 times 4 squared plus 4 times 4, take away 3. The answer is 5. If I plug in 1 for t and I solve it, That would be 1 negative a half times 1 squared plus 4 times 1, take away 3. So just plug in 1 for t. The answer is 1/2. So the displacement, where did the particle end up? Is at 9 over 2 or 4.5. Then it says, find the velocity of this equation. If you're given the position to find the velocity, you take the derivative. So do we remember how to take the derivative? So 2 times negative a half is negative 1, and subtract the exponent. So 2 subtract 1, the exponent now is 1. The derivative of 4t is 4, and the derivative of negative 3 is 0. So there's the velocity equation. If you sketch the velocity, it's a line. You would start at positive 4, and you go down 1 and to the right 1. So draw the line that does that. So there's the velocity equation. Then it says integrate from 1 to 4. So from 1, that's right here, to 4, what shape is that I would find the area of? So that's the area of a triangle. That's 1/2. The base from 1 to 4, the base is 3 from 1 to 4. The height, what's this height right there, is 3 as well. So if I multiply this together, 3 times 3 divided by 2, what did I notice? Is the displacement is equal to that. The definite integral is the displacement. And it takes into fact whether it's positive or negative area. If I ever needed to find total distance, I would have to do the absolute value of this, which would be the speed. Because if I did the absolute value, that would make everything that's a negative area, it would reflect up and become a positive area. So if I wanted to find the total distance, I would integrate with the absolute value of that. All right, continuing. It says the derivative of f is a continuous function from a to b. So first, the derivative is a continuous function. If that's the case, then if you have an upper and lower bound, so the lower bound is a, the upper bound is b, and it's the derivative, when you integrate the derivative, it's now the function. You plug in the upper bound, you plug in the lower bound, and subtract the two to get your answer. That relationship is called the Fundamental Theorem of Calculus. So integrate, then plug in the upper bound, plug in the lower bound, and subtract the two answers. Upper bound, subtract the lower bound. All right, let's practice the Fundamental Theorem of Calculus. All right, so step 1, can you integrate what you see, and then we'll do the substitution. So right now the way it looks is not very calculusly, so I need to make it look so that calculus will be nicer to me. So instead of the square root, I'm going to go 2y to the 1/2 plus 1 dy. So I'm going to integrate with respect to y. So integrate 2y to the 1/2. So take the y to the 1/2, add 1, and it is 3 over 2. I am going to do, instead of dividing by 3 over 2, I'm going to do the reciprocal, and I'm going to combine that together in a second. The integration of 1 is y, and we're not going to do a constant. So for a definite integral, we don't need that constant. Instead, we are going to substitute in with our bounds, and our bounds go from 0 to 4. So to show that, we're going to draw a vertical line and show it's going from 0 to 4 rather than an integration sign. So we've already integrated, and now we're going to integrate, or we're going to substitute in from 0 to 4. So we start with the upper bound. So 2 times 2 is really 4. So I'm going to plug in 4. I'm going to put parentheses around it. So you plug in 4. There it is. Subtract. Now I'm going to plug in 0. Same equation. It's the upper bound, subtract the lower bound. You plug in 4, you plug in 0. Each one you have to answer separately. Answer this separately, answer this separately, and then subtract the two answers. So this is good practice on the left side. The right side is 0, right? 0, 0, 0. The right is 0. The left, the square root of 4 is 2. 2 cubed is 8. The square root, the denominator means square root. The square root of 4 is 2. 2 cubed is 8. 8 times 4 is 32. And 32 over 3. How do I create common denominators? The denominator you don't see for 4 is 1. The denominator needs to be 3. So I'm going to multiply top and bottom times 3. So I have 12 over 3. And remember, the right side equaled 0. So altogether, 32 plus 12 is 44 over 3. If there was free response, this right here would be your final answer. You do not need to go any further. If it was multiple choice, this would likely be one of the answer choices. And you'd have to have the skill without a calculator to be able to simplify that using your number sense. All right, number 11. Let's try that. I used up all this room here for number 10. Number 11. I'm going to do it on a separate piece of paper here. Do it like this. So for number 11, how will I integrate that by hand? I'm going to integrate and then plug in the bounds. So what is the integration of that? So I want you to look carefully. This is the anti-chain rule. What is the derivative of 4t plus 1? It's 4. That needs the hook of a 4 in front. That's the last lesson. But if you look carefully, there was a 1 in front, not a 4. So how do I undo it? Is I can divide those constants. 1/4 undoes it. That is equivalent, but I can now do the anti-chain rule. So the anti-chain rule, the 1/4 is a part of it. The 4 is part of the chain, and I just need to worry about u. Add 1 to the exponent. That's 6. And then divide by it. And I'm going to integrate that with the bounds. I'm going to plug in. The lower bound is 0, and the upper bound was 4. 1 over 4 and 1 over 6. Together, 1 over 4, 1 over 6 is 1 over 24. That 1 over 24, when you substitute in, can simply be in front because the 1 over 24 belongs to the upper bound and the lower bound. Because it belongs to both, we can put that in front of the parentheses and then not worry about the fraction. I can just worry about what's inside the parentheses. So first, what number do I plug in here? Number 1 over 24 is in front. So just worry about the parentheses. Plug in 1. 4 times 1 is 4. And then 4 plus 1 is 5. So 5 to the exponent 6. I don't even know what that is. Subtract. Plug in 0. 4 times 0 is 0, and 0 plus 1 is 1. So it's 1 to the exponent 6. I know that one. That's 1. And you have your answer. If you want to, you can type that in a calculator and make it a lot prettier. But there's no constant at the end. A definite integral, there's an actual number for an answer at the end. So that was number 11. Number 12. Do I have room? Here, I'll do it on here. I got room for number 12 here. Maybe. No, let me do it here. Number 12 is a longer one. I'm going to fold this up. In this sheet of paper, I'll scan it so you can see it. All right, can you integrate that? If I look at the denominator, this again is from the last unit. If u was 2x subtract 1, I take the derivative, The x doesn't help me. So for instance, if I write this so it's calculus friendly, this is what it would look like, and it would be a negative 1/2. And if I take the derivative of 2x minus 1, you get 2. But in front, I don't have a constant, I have a variable, and I can't undo the variable. So therefore, I can't just do the anti-chain rule. I must do a substitution. So we're going to do it together, one step at a time. U equals 2x minus 1. You can do that. X. To get x by itself, we're going to add 1 and then divide everything by 2. So you add 1 and then divide everything by 2. To take the derivative, it's dx and 1/2 du. So you could have went add 1 and divided everything by 2. That's what we did. But that 2 belongs to both, and it's easier to separate them when you take the derivative. So that's really 1/2 u plus 1/2. They're equivalent. Now go back to your question. Where there's an x, I'm going to plug in 1/2 u plus 1/2. 2x minus 1 is u, and that's to the exponent negative 1/2. And dx is 1/2 du, like the problem we did today in class. Where can that 1/2 go to make life easier? Is in front of the integration. That's one of the properties of integration, is that a constant can be written in front of the integration. So that's what I'm going to do. And then I'm going to do some algebra. So can you distribute? 1/2 u times u to the negative 1/2. Add the exponents. Positive 1 and negative 1/2 makes that positive 1/2. Multiply it, and it's 1/2 u to the negative 1/2. Again, I want you to notice, if we want to make life easier, we could actually factor out the 1/2 and make it join the other 1/2 to make it a quarter. But we're going to leave it just how it looks like right now. We're going to integrate. So that 1/2 is going to stay in front. I'm going to do big parentheses, so you know that 1/2 distributes to everything that we're getting. How do I integrate? What do I do to the 1/2? Is I add 1. And if I add 1, it's now 3 over 2. Instead of dividing, I'm going to multiply times the reciprocal. Remember, there's a 1/2 in front, inside. I'm going to do that again. So already in front is a 1/2. I'm going to leave a space. Add 1 and it's 1/2. Dividing by 1/2, the reciprocal of 1/2 is 2. And we don't need the candy. Instead, we're going to show that we're going to do a substitution. It's a definite integral. We're going to plug in 5 first and then 1. It goes from 1 to 5. So no constant. Now, the good news here is, let me change this from 1 to 5. The good news here is I don't need to go back to x. So, do you see how I went 1 to 5? That 1 to 5 is with respect to x. I can change the bounds to respect to u. If I come back here and look, what does u equal is 2x minus 1. So in other words, I can take the upper bound, which is 5, that's 2 times 5 minus 1, till with respect to u, what's the bounds? So plug in 5 for x, 2 times 5 is 10, take away 1 is 9. So it's no longer 5, with respect to u, the upper bound now is 9. That way I don't have to plug x back in. What was the lower bound? 1. So in terms of u, you would go 2 times 1, take away 1. Well, guess what? The lower bound stayed the same, so I don't need to cross it out. When you plugged in 1, you got the same lower bound. But now we're going to use these numbers when I do my substitution. So in other words, right now I'm not going to put x back in. I don't need it. I can just use u. So in front, we have 1/2. Notice how the 2's divide out. That is 1/3. And then what number do I plug into u, the upper bound, which is 9? Again here, it's going to have its own parentheses. The 1/2 times 2, the 2's divide out, so you're just left with u. And we said the upper bound for u is 9, and that's to the exponent 1/2. So that's the upper bound. We're going to subtract the lower bound. And again, we kind of have brackets around the whole thing because that 1/2 in front belongs to both. We're going to do it all over again. This is going to take some discipline, a little bit of practice, but once we understand it, it isn't too bad. Again, the 1/3, but instead of 9, the lower bound is 1. So I plug in 1 and then close it with brackets. So I have the upper bound I plugged in, subtract the lower bound. It doesn't look pretty, but that's okay. If this was free response, it would be done right there. You can't make it look prettier. But if I did have to go further, could you? Well, let's do it together. The 1/2 in front stays. Inside the first parentheses, the square root of 9 is 3, and 3 cubed is 27. 27 divided by 3 is 9. The square root of 9 is 3. So I simplified with the 9's, minus, now let's do it with 1. 1 to any exponent is 1. So that's 1/3. 1, and that's the square root of 1, but 1 to any exponent is 1. Let's keep going. 9 plus 3 is 12. 1/3 plus 1 is 1 1/3. But to put it together, it's better as an improper fraction. So that's 4/3. Bring this together. Put a 1 underneath the 12. Common denominators, top and bottom, times 3. So it's 36 take away 4. All over 3. 36 take away 4 is 32. 2 goes into 32 16 times, and you have the answer 16 over 3. A good practice would be type this with your calculator and see if it answers, and the same answer comes up as 16 over 3. I know that takes practice. I know that's really good calculus. And we will get there if you want to be there. All right. Last part of the lesson. It says start plus accumulation method. Meaning you're given a starting point and we can integrate, but there's one of the bounds I do not know. So here we know from the Fundamental Theorem of Calculus, when you have a derivative and you're integrating with an upper and a lower bound, you integrate. So instead of f prime at x, when you integrate, that's now just f at x. And then you plug in the upper bound, which is b, and you subtract and then plug in the lower bound, the Fundamental Theorem of Calculus. I can rearrange this equation. If I wanted to get this by itself, my upper bound, how would I do that? Well, I would just add f at a to the other side, and that's what it is. So the upper bound part, I can then rearrange that equation to solve if it's asked in that way. So it's taking the Fundamental Theorem of Calculus and rearranging the equation so I can solve what's being asked. So let's look at 13 and 14 to see how that's applied. So in example 13, you're given the derivative. And you're told that f at 0 equals 4, and to find f at 2. You're given the starting value, meaning you're given the lower bound. The lower bound is 0, and when you plug it in, the answer is 4. But you're not given the upper bound. Can you see how this equation is for the upper bound? So if I fill in with that equation, the upper bound is f at 2. I don't know what it is. The lower bound, f at 0, I do know what that is. And then the integration. The lower bound is 0, the upper bound is 2, and the derivative, right, that was given, which is 3x squared plus 3. And now I can solve for what's being asked. What's that value of that at the end? So I want to know what f at 2 equals. So f at 0 is equal to 4. Integrate. Add 1 to the exponent. So if I add 1 to the exponent, it's x cubed, and then divide by 3. Well, 3 divided by 3 is just x cubed, and then 3, the integration is 3x. And I'm going to integrate that from 0 to 2. So what does that mean, to integrate from 0 to 2? That means I first plug in 2, then I plug in 0, and I subtract the two answers. So in this scenario, when you plug in 2, you get 2 cubed, which is 8, and 2 times 6, or 2 times 3, which is 6. So again, you get 2 cubed plus 3 times 2, which is 6. And then, when you plug in 0, well, the answer is 0. And when you subtract 0, it doesn't change the answer in front. So when I put it all together, 2 cubed is 8, plus 3 times 2 is 6, so 8 plus 6 is 14. And I get my answer. So the question is, what is the value of f at 2 with the information given? And the answer is 18. That's rearranging the fundamental theorem of calculus to find something that's missing. All right, 14. And then you have some work to do with your assignment and reviewing for your test. And I promise you that next week we will have time to work, and maybe after school too. If an object's velocity is v at 2 equals 2 to the exponent t, and s at 2 equals 8, find s at 3. So we're going to use this equation above. We're given the lower bound to start with. So if I want to find s at 3, start with the lower bound. And when you plug in the lower bound, the answer is 8. Then we're going to add to it the integration with the lower bound is 2 to the upper bound is 3. And we're going to integrate 2 to the t. And the variable is dt. Later in life, we're going to learn how to integrate an exponential function. But that moment is not now. So you are going to use your calculator. And then you're going to solve for s at 3 with your calculator. So do you know how to use your calculator? Let me do it too right here for you. And again, thank you to Jesus for helping us find it easily. For some reason, I still, just for integration, like going to menu. I like pressing calculus, and I like going to integral. But you can also press that other button. And this is integrating from 2 to 3. And the equation is 2 to the exponent. And I'm going to use x rather than t. I wonder what would happen if I use t. Let me use t and see if it's comfortable with that letter. I'm going to experiment. And then integrate with respect to t. Now, to that answer, we're going to add 8. And let's see what happens. So it seemed to like it okay. So you can use any letter you want. You can see the exact answer is there. If I want to round that answer, I would press Control and Enter. And again, we're going to learn to truncate, and the answer is 13.770, or you can write down 13.771. All right, now we got to work, right? Now we got to practice with our assignment before I see you on Wednesday. So it's a full week before I see you. I'm going to miss you guys.